friends, welcome back to our channel. So in the previous session we have seen how to create a circular linked list and also how to display the nodes of a circular linked list. And the major difference we have seen of circular linked list over the single linked list is, in the single linked list the address field of the last element will be filled with null character, and coming to the circular linked list, the address field of the last node will be filled with the address of head. So that's the only difference between the circular linked list and single linked list. Now in this session we will see one more operation on circular linked list, that is insertion. Circular linked list. Now let us see the insertion. So in this insertion we will see the three cases. One is inserting the node at the beginning, inserting the node at the ending, inserting the node at specific position. Right. Now let us take an example so that you will be better understanding. Right. Let us consider one example with the 4 nodes. Right. The address of first node is 1000, 2000, 3000, 4000. Let it be 10, 20, 30 and a 40. Here it will store the address of the next one, that is 2000. It will store the address of next one, that is 3000. It will store the address of next one, 4000. Here 40 is the last element, so according to the definitions, the last element or last node of the circular linked list will be having, it will holds the address of the first element. So first element address is 1000, so here it will be 1000, so that there will be link from this to this one. Yes, this one is a head and this one will be the tail. We know that, right? Now insertion at beginning. Insertion at beginning, that means let it be the value is 5. So first we will write the output. What is the output after inserting the element? C. See 10, 20, 30 and a 40. Two thousand, 3000, 4000 and 1000. Right. Now let us see if it is a new. That means we need to insert this new into this linked list. So for that we know that we have to allocate the memory by using the dynamic memory allocations. So first new is equal to struct node star, which returns a pointer using a malloc function, size of struct node. Right. So a pointer will be assigned to this new, this one. Let it be 500. 500 is the address of new, and we have to read the value. So scanf %d ampersand value. So let it be value is 5. The value is 5. So 5 should be inserted here. Right. the address is 500, it is a new, right? So the 5 should be inserted here. Now new of data is equal to value, right? The first step is new of data is equal to value. That means this is the data, this is the next. So new of data is equal to value, so 5 is placed here. Hope you understood. Next, new of next. What is the new of next? Here which address it should be? So it should fill with the address of head. So new of next is equal to head, right? So new of next is equal to head, so the address will be placed here. So automatically a link is established. A link is established, right? Now we have to change the tail, because according to this, the tail, that means the last node, should contain or should hold the address of first one, but here it holds the address of second element after inserting new one. So we have to change the tail. Where it should be changed? This position. Here it should be 500. So how it will be? Tail of next. Tail of next is equal to, what is this? 500. New, the address of new. So new, right? So a link will be established from the ending node to this one. Now head should be changed, because head is in the second node. Now head should be changed to first node. So head is equal to new. So here head will be replaced and it will be assigned to new, right? So this is a small logic for inserting an element at the beginning, right? So once again, just we will observe, this is the new element. In this new element, here the data, the actual value should be placed in the data field. In the address field, the first element, this element address should be placed. So next, new of next means this field is equal to head. So what is the head address? 1000 will be placed. So a link is established now. Now tail should be linked with the head. So tail of next is equal to new. Now head will be moved to new. A simple logic for inserting an element at the beginning in the circular linked list. Okay, so hope you understood this one, right? Now we'll go with the second case, that is insertion of an element at the ending position. Right. This is the tail, and let it be, this is the 5000, and this is the data field, this is the next one, and this is the new, right? So second case, that is insertion of an element at ending. Insertion of an element at the ending. So this is the output, and here we have to establish the link. Now let us check it out. So first, we have to create a node, so we have to allocate the memory. So the same step we have to write it here. The new is equal to struct node star malloc size of struct node. So now we have allocated some memory to the new, that is some 5000. Now we have to read the value scanf %d ampersand value. Let it be 50. So where this 50 should be placed? Here itself. What is the value here? I mean, what is the variable here? New of data. So new of data is equal to value. So automatically the 50 will be placed here. Right? Now here in the place of tail, what should be placed? The address of new. So here that means tail of next, because we have to establish the link between this node and the newly added node. For that purpose, tail of next is equal to new. Automatically the 1000 will be replaced with the address of new, that means 5000. So automatically here the link is disconnected and here the link is established. Hope you understood this one. Tail of next is equal to new, right? Now what should be placed here? Because this is the last element, the address field of the last element should have the address of head. So here it should be placed the address of head, that means 1000 should be placed here. 1000 should be placed here. So for that, new of next is this one. New of next is this one. New of next is equal to head. New of next is equal to head. Automatically the 1000 will be placed here and the link is established now here from last element to first element. Now the tail should be moved to the last one. Tail. So previously the tail is last but one position. Whenever the node is added, the tail should be moved to the last position. So now we have to assign the new to tail. Tail is equal to new. Obviously this tail will be assigned, removed here and it will be assigned here. Right? So this is the output after adding an element at the end of the circular linked list. Right? Hope you understood this one. So first we are just adding the value and then we are establishing the link from previous node to last element. That means this one, tail of next is equal to new. So next, new of next is equal to head, because as it is a circular linked list, new of next is equal to head. So if you place new of next is equal to null, automatically this will be coming to single linked list. Right? A slight difference. So unless you draw the diagram, you can't write the code. Unless you remember or mug up. Right? Just draw the diagram and finally we know what should be stored in the address field, what should be stored in the data field. Based upon that thing, just write down the statements. It would be very simple. Right? So this is all about the second case, that means inserting an element at the end position. Now the third case, let us see the third case, that is insertion of an element at a specific position. So we will specify some position and then so the data must be inserted at that particular position. Right. We will go with the third one. Right. See, here we need to take the third one. Specified position. Here we have to take two inputs. One is value and position. Value and position. These are the inputs to be taken. So two scanners to be written. Now let's write the output so that you will understand. Right? Let the position be 2. At the second position 0, 1 and 2. So here the logic is not changed for both the single linked list or double linked list, because the position, specified position, the logic is same for both the single linked list and circular linked list. Now let it be, there is a connection here and we need to insert an element here itself. We need to insert an element here itself. So it is the data, it is the next, and this is the new. Right. Now this is the head and this one will be the tail. See, now just read the value. First we have to write the memory allocation. Just before we have written that new is equal to struct node star, so that the address will be assigned to new. Let the address will be 2500 here. 2500. Value will be 25. Let it be. The value written is 25 and the position is a 2. At the position 2. So we have to shift the head from current position 2, that means the first element 2, position -1. So for I is equal to 0. So we should not change the head. So just initialize head to some temporary variable. Temp is equal to head. Now for I is equal to 0, I less than position -1, I plus plus. So it will move until it reaches position -1. What should be done? The temp is equal to temp of next. So simply we are moving the temporary variable. So in the first iteration it will move. So initially the temp will be here, right? After first iteration this temp will be moved to this one, right? And whenever in the second iteration, that means I is equal to 0. So here I is equal to 0. Whenever I is equal to 1, the condition is false because 2 minus 1, 1 less than 1, condition false. So it comes out from the loop. Now what we have to do? So here, right? So carefully observe. We have to establish the link between the newly added node and the next node, and the previous node and the newly added node. Right. First we have to establish the link between the current node and the next node. What is the address of next node? 3000. Where it is been? So it is in this position. That means temp of next. Temp of next. Right? See. Now we will see. So we can simply write new of data is equal to value. So automatically this 25 will be placed here. 25 will be placed here. Will be placed here. Now new of next. New of next. What should be placed here? 3000. Where? Temp of next. Right? Temp of next. Temp of next. See. Now after executing this statement, temp of next is 3000. 3000 will be placed here. That means a link will be established from 25 to 30. Now here, see, here that means temp of next, it should be assigned with the address of new. Temp of next is equal to new. Automatically the 3000 will be removed, so this connection will be disconnected and 2500 will be saved here, so it will be connected. This node will be connected to this node and this node will be connected to this node. So just follow the address, just follow the statements. Okay, so hope you understood this one, right? So first we have to place the data. There is no issues. Next, new of data is equal to value. The statement is normal, right? Next, new of next. What should be placed here? New of next. So here it should hold the value of, it should hold the address of 30. What is the address of 30? 3000. Where it is placed previously? In here, 20th. So temporary. So temporary of next. So new of next is equal to temporary of next. Now a connection is established between this node, a newly added node, to the next node. Now we have to place the connection between the temp node and new node. So that's why we have given temp of next. Here we have to hold the address of new. So that's why temp of next is equal to new. So this is how we have to insert an element at the specified position, right? So hope you understood the three cases. So how to insert an element at the beginning, how to insert an element at the end, and how to insert the element at specified position, right? So hope you understood this session. If you are having any doubts regarding this session, feel free to post your doubts in the comment section, so that definitely I will try to clarify all your doubts. And if you really understood my sessions, like my sessions, share my sessions with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.